All right, so back at radicals again here. We're looking at the second part of section 5.6 in terms of radical expressions. If we start looking at how to simplify radicals and how to rationalize denominators using our multiplication and division properties in the first part. Here we start to take a look at what it means to actually add and subtract radicals. Adding and subtracting radicals, you can see here as I have typed out here, you can only add or subtract radicals if the same number is under the actual radical. Basically what that means is they need to be like terms. We talk a lot about like terms when we talk about variables. Can I take 2x and can I add that to 3x? Well, I've got the same variable and each variable has the same power, and so those are like terms, and I can make that 5x. If I have 2x squared and I want to add that to 3x, can I do that? Well, they both have the same variable. This one has a power of 2 and this one doesn't. So those are not like terms, and so I have to leave that just the way it is. The same thing pretty much holds true when you are trying to add or subtract any type of radical. Square roots, cube roots, fifth roots, 176 roots, they've got to have the same index. So they both have to be square roots, or they both have to be cube roots, or all 10 of them have to be fifth roots. Okay, they have to have the same index. And then after that, they have to have the same number underneath. So you can see here in this example, I've got the square root of 7 plus the square root of 7. The one thing most of us are going to do, like, oh, hey, that's the square root of 14. Sweet, I got it. I am so good at math, except for one thing, that is not right. Okay, the square root of 7 plus the square root of 7 is not the square root of 14. Again, we kind of think about it in terms of our variables here. If I have 2x's here and I have 3x's here and I want to add those together, that gives me a total of 5x's. So when I'm taking a look here at radicals, I've actually got one radical 7. I'm going to add to that another radical 7, or 1 square root of 7 plus another square root of 7. So that gives me a total of 2 square roots of 7. And so it's like you're trying to total up how much you have. This example might be a little bit easier to understand. Again, both roots here, both radicals are both square roots. I've got the square root of 3 and the square root of 3. So I have the same number underneath that radical symbol, which is good. They both have the same index. Well, I have 8 here, and I want to subtract 4 from that 8. Well, I can do that. So 8 radical 3 minus 4 radical 3 leaves me with 4 altogether. Because I had 8, I'm taking away 4. I've got 4 square roots of 3 left over. So when the number underneath the radical symbol is the same thing, life is good. Just to show you it works with other things, if I have 10 cube roots of 9 and I want to add to that 4 cube roots of 9, because I have cube roots, because they both have a 9, then I can add those together and say, hey man, I've got 14 cube roots of 9. That'll probably get you a ham sandwich in India. Okay, maybe some other country, I don't know, Canada. It's always one of my favorites. So that's how it works when the numbers underneath the radical symbols are the exact same thing. Well, what if the numbers underneath the radical symbol are not the exact same thing? That's what you'll see in these next two examples. We've got to apply those techniques that we've been learning about in terms of simplifying radicals to see what we can come out with. So here in number 9, we've got the square root of 12 plus the square root of 48. So we've talked about trying to find factors of our numbers here that are perfect squares. In this case, I know that 12 is the square root of 4 times 3, or the square root of 4 times the square root of 3. I can take the square root of 4, and that's 2. I cannot take the square root of 3, so I'm going to put that back underneath my square root symbol. So now I need to somehow simplify the square root of 48. A little trick we can use is this. I know that my numbers underneath my square root symbol have to match up. I've gotten this one broken down to where I have the square root of 3. So I'm really looking for 48 having some type of factor of 3 in it. So to put it in simplest terms, whatever number I end up with here, see if that will divide into your other number. And it does. 48 is really 16 times 3. Well, I know I can take the square root of 16. That's 4. I know I cannot take the square root of 3 evenly, so that goes back underneath. Now I've got square root of 3, I've got the square root of 3, and so I can add those together and get 6 square roots of 3, or 6 radical 3. All right, so we can use our work in one problem to help us with the other part of the problem. Kind of like in number 10. Square root of 5. The only factors of 5 I have are 1 and 5. There's no way to break that down anymore. So since this is already kind of simplified, I'm going to use that factor of 5 in each of these. 5 goes into 20 4 times. 5 goes into 125 25 times. Well, again, I can take the square root of 4. That's 2. I cannot take the square root of 5 evenly. Put a 1 out there in front if I need it. Minus, I can take the square root of 25 and get 5. And again, since I cannot take the square root of those, they go back underneath the radical symbol. So now I can start to look to add and subtract my like terms. Everything has a square root of 5, so I can put together the numbers that are on the outside. So I know that 1 plus 2 is 3. I know that 3 minus 5 is negative 2. I keep my square root of 5, and so that becomes my final answer. So we'll take a look at more of those in class when we come back. And if you have any questions, or if you need to go back and rewind, take a look at it again. If you have questions beyond that, jot them down and bring them to class. We'll talk about it, because I love talking math. See you then. Bye.